This is your physics educator, and today we will learn about the sign conventions and ray diagrams in reflection. Okay, and in upcoming videos I will upload more concepts. Right, so first we will try to understand sign conventions in reflection and refraction of mirrors and lens respectively. Okay, both will have the same sign convention, that is why we are doing it together. So one thing is Cartesian sign convention. Cartesian sign convention. So Cartesian sign convention, it follows the same rule as in two-dimensional coordinate geometry. The two-dimensional coordinate geometry, okay, contains this Cartesian plane having xy axis with origin. As we know, all the distances are measured from origin. So taking this as reference, if I go in this direction, it will be taken as positive. If I go in this direction again, it will be taken as negative. Anything above the principal axis will be taken as positive, and anything below the principal axis or this x-axis will be taken as negative. That is our general sign convention. Okay, this is known as Cartesian sign convention. In the similar manner, if I will take any mirror, okay, of course we are talking about a spherical mirror or even plane mirror. It also follows the mirror formula. Suppose this is any plane mirror, okay, and this is its principal axis. So this will be the direction of incident ray. Okay, this will be the direction of incident ray. This is incident ray. Okay, so exactly the pole of mirror, this we take as a pole of mirror. Pole of mirror will be taken as origin. Okay, the first rule in the sign convention is that all the distances must be measured from pole. Okay, it means pole is your 0, 0. Okay, now in Cartesian sign convention we have x-axis, positive x-axis, negative x-axis, but here we have incident ray. So if you will go in the direction of incident ray, let's say if you are going in the direction of incident ray, it will be taken as positive. Okay, so second thing we can write, any distance measured in the direction of incident ray, will be taken as positive. Okay, and anything opposite to incident ray will be taken as negative. Right, so I am adding here, and vice versa will be taken as negative. It simply means that if this is the pole here, center of the mirror, if this is the pole, right? This is my incident ray, this is my incident ray. Then if I am measuring anything in this direction, it will be taken as negative. Okay, it will be taken as negative. Of course, as I said, this is the principal axis, this is the principal axis. So just like Cartesian sign convention, any distance measured above the principal axis will be taken as positive, any distance measured below principal axis will be taken as negative. So we will include this in our theory, that any distance measured above principal axis will be taken as positive, and below the principal axis it will be taken as negative. Right? So the same rule applies for any curved mirror as well. Suppose this is my concave mirror, so this pole will be taken as origin, anything measured in this direction. Of course, first you should know incident ray must always be incident in the in front of the reflecting surface. Okay, there is no use of incident ray being incident from this side, because it will not form the image. Okay, the incident ray must always be incident towards the reflecting surface. So this is my incident ray. Now if I am measuring anything in the direction of incident ray, I will take it as positive. Opposite to the direction of incident ray, it will be taken as negative. But please remember, I have to take this as reference, pole as reference. I have to start in this direction from here, or in this direction from here, right? So pole is our origin, right? Okay. Now in the similar manner, I can say that anything above principal axis will be positive, below principal axis will be taken as negative. And in this type of lens, which is convex mirror, again the same idea, this will be positive, above will be positive, above again will be positive, of course, but below the principal axis it will be taken as negative. This distance will be taken as negative. For lenses, the two types of lenses, as we know, this will be the optical center, O. So this will be the origin, O will be taken as origin. Anything measured in this direction will be negative, anything measured in this direction will be positive. Above the principal axis positive, below the principal axis negative. Similarly for concave lens, again the same idea, this will be the optical center O. From the optical center, if you are measuring in this direction, positive, if you are measuring in this direction, negative. Above the principal axis, positive, below the principal axis, negative. Right? Now you will come to know, using the same idea, that why focal length of certain mirrors are positive and certain mirrors are negative. Right? And then some nomenclature also you should know. This U means it is the object's distance from pole of mirror or optical center of lens V is image distance from similarly pole of mirror or optical center of lens, right? F will be the focal length as per our requirement, and R radius of curvature. This we already know, but again for revision I have told. Now simply think, if I will draw any spherical mirror, let's say I am drawing concave mirror, okay? So for concave mirror, always this will be the direction of incident ray because my reflecting surface is pointing in this direction. So exactly incident ray should be towards reflecting surface. This is my reflecting surface. This is my reflecting surface. And this is my incident ray. In short, I am writing I ray. Okay. So as we know, this was a part of a sphere. This was a part of a sphere. So this sphere will have its center this side. Now you can see from the pole, it is measured opposite to the direction of incident ray. So minus R. Suppose focus is somewhere here, F. So from the pole, I am measuring it in this direction. So that is why it is minus F. And ray is always incident from the object. Ray is always incident from the object, right? So any distance measured in this direction is negative, so minus U. Okay. Again, the location of image will tell that whether the image is V is positive or negative. If let's say V is formed in this direction, image is formed here, somewhere here, image. So in this case, V will be negative. But let us suppose if image is formed here or appear to us that image is getting formed here, then we take V as positive. Is that okay? All of you? So just for a practice again, for this type of lens, you can see it is the part of the sphere. It is the part of the sphere. So this sphere will have its center this side. This is the direction of incident ray. Now I am measuring this radius in the same direction as incident ray. I am measuring my focal length in the same direction as incident ray. So you can see for convex mirror, the focal length is positive. The radius of curvature is positive. Okay, by convention, for this focal length will be positive, but for this focal length will be negative. Okay, but U, the distance of the object from here, object will always be this side. Okay, object will always be this side. So if measured from pole, this is my pole, this will be minus U. Again, formation of image will determine whether it will be negative V or positive V. Negative V or positive V. That we will talk in the next video when we will solve the numericals. Okay, so these are the sign convention. Next video will be on rules for drawing ray diagram. Rules for drawing ray diagram. Okay students, thank you. We will meet again. Bye.